this video, we introduce two concepts, fungibility and ring fencing, in the context of IFRS 4 and Solvency II requirements. We'll also look at an example involving our 6 real-life LOBs and compute the various IFRS 4 metrics, in particular risk margins, and also Solvency II metrics, fair value liabilities, SCR, risk margins. For the Solvency II 1-year risk horizon. We'll conduct similar calculations in video chapter 5.7 for the ultimate year risk horizon. Now, exposure draft 2010 of IFRS 4 does mention that both standards, solvency standards, or does allude to the fact that both the solvency standards and the IFRS 4 standards require the estimation of cash flow distributions. Well, this is something we have mentioned repeatedly in these videos and also in Chapter 4 videos on capital management, that what's critical in calculating all these metrics is the liability stream by calendar year, the distributions of the liability streams by calendar year. Their correlations are also important, and they're driven by parameter uncertainty, which you will see in video chapter 5.6. So, and these distributions should be based on explicit and auditable assumptions. And returning again to this exposure draft 2010, there is a mention of each of the permitted techniques for measuring risk adjustment builds on a probability distributions of the underlying cash flows. The concept of fungibility also comes into QIS 5, SCR 11. Now, what does fungibility actually mean? If you've got two LOBs, typically if you get full risk diversification credit and you look at the distribution of the aggregate of these two LOBs, you are implicitly arguing that a loss in one LOB that is less than the mean, let's call that a surplus or profit, can be used to pay for losses in the other LOB that exceed the mean. And that's the standard approach. Now, we call that full fungibility. A surplus in one line can be used to supplement a deficit, a loss exceeding the mean in another line. What about no fungibility? What does that actually mean? That means you actually have to set up a risk fund where the risk fund typically will have to be larger. There's got to be more money in your capital risk fund. And now, if you don't have fungibility, because now if the loss in a particular line is less than the mean, let's call that a surplus, it's retained within that particular line and cannot be used to pay for the losses in the other line. So in that particular instance of no fungibility, you need to have a larger risk fund. Surpluses cannot be distributed across the lines of business. But you can also have partial fungibility. What do I mean by that? You can set up portfolios of LOBs, different groups of different portfolios. One portfolio might be a territory or country or a certain class of business units. Now, you could have full fungibility in LOBs in the same portfolio, but if you've got two LOBs that are in different portfolios, there's no cross-subsidization of surpluses, there's no fungibility. You can always go to this part of our website. There's a whole discussion of Solvency II, 1 year, ultimate year risk horizon, consistent estimates on updating. Some of these you'll see in the videos. IFRS 4, variation estimates of prior year, accident year ultimates, conditional next calendar year. There's some further reading and so on. Now, why don't we try and illustrate this with some discussion in a PowerPoint display. So here in my PowerPoint display, the way to think about the problem is in terms of a risk fund or a capital risk fund. You have a risk fund, and you draw on that risk fund anytime losses exceed the mean for the aggregate. So let's suppose we only have two LOBs, LOB1 and LOB2. You access the risk fund when the sum of the two losses exceed the mean for the two lines of business. Okay, and you know that means are additive. All right, let's now assume that for LOB1, that in fact is the loss, the green part, and the mean for LOB1 is there. So that's the distance for LOB1. Okay, so in this particular example, because the loss is less than the mean, if you like, there's the surplus here. Now, is the surplus going to be used to pay for the other line of business that exceeds the mean or not? Let's look at it. LOB2, that's the mean, but the actual loss exceeds the mean by this pink part. This green is the sum of the two means. Okay? This pink is this pink, and that little square there is this surplus, and it also sits here, if you like. Okay, so first example, what do you draw from the risk fund if you do share surpluses between the two LOBs? Or if you like, they are fully fungible. Okay, now for this LOB2, the amount that exceeds the mean is this amount, but you can use this surplus to fund that. And as a result of that, what comes out of the risk fund is only this amount. This whole pink, which is there, minus this surplus, which you obtain from this LOB. Because surpluses are shareable, you got full fungibility. So again, the draw on the risk fund is not this amount. It's this amount minus this part here. So it's that pink minus the surplus that comes from there. Let's suppose now they're not fungible. If they're not fungible, this surplus here cannot be used to pay for this pink. In other words, it is retained within LOB1. So what you need to draw with the risk fund is larger. You need to draw that amount from the risk fund. So in the case of non-fungibility, the drawing on the fees fund is larger because you can't use that particular surplus. Risk fund is larger, the capital risk fund is larger in the context of non-fungibility. I mean, if you wanted to look at it in terms of random variables and how you might do the calculations and not necessarily think in terms of a risk fund, one way of thinking, another way of thinking of it just mathematically, but I don't think it's intuitive. I think this story represents the concepts in a better way than this mathematical story. All you're really doing is, when you calculate the VAR of the aggregate in the context of non-fungibility, you're calculating the VAR of the aggregate of the maximum of L1. L1 is the distribution of the losses in LOB1. That's the mean. And that's the maximum of the losses distribution, loss distribution for line of business 2 and its mean. All we're really saying here is that if the loss is less than the mean, then the payment you make is actually the mean. It's another way of looking at it. But I think this way, in terms of what's in the risk fund or how large the risk fund has to be, the capital risk fund has to be, is a better way of actually representing it this way pictorially. So now let's look at an example involving our 6 LOBs. Let me run the model twice. Okay. Remember, we've got 6 LOBs. I think LOB was the most, 4 was the most volatile, but LOB3. So the first, let me do the forecasting first for the 6 LOBs. I'll do that twice. So I can run an instance of Solvency II 1-year risk horizon metrics, full fungibility, and then no fungibility. Load, combined, conservative. Okay. Let's look at the forecast summaries, just to remind ourselves which is the most volatile, which is the largest proportion. Well, these two summaries should be identical. We use the same forecasting scenario going forward. And you might remember that LOB4 is the most volatile. LOB3 has got the lowest CV, but LOB3 is the largest line of business. LOB1, I think. So you'll see later on in another study that you know, when are you really in the distress situation the next calendar year, and you'll find out that most of the distress is coming from LOB3, and then I think maybe LOB1 or LOB2, I can't remember exactly, but you'll see that in video chapter 5.6 when we discussed distress samples. So now we're going to do two simulations. We're going to, first of all, we're going to do only for the reserve part. We're going to assume full redistribution of surplus across LOBs, so they're fully fungible. That means there's only one portfolio. So the portfolio consists of all the LOBs. I can set up other portfolios. I mean, I can remove that one and therefore have LOB3 as its own portfolio. And then, if you like, I can add to that portfolio, say, LOB5. Like, oops, what did I do there? I clicked on the wrong one. Add to selection. So let's put that there. And now let's add to LOB3, LOB5. So now I've got two portfolios, LOB3 and LOB5. They are fungible, but they're not fungible with, across this other portfolio that I've labeled 1. So I can set up separate portfolios. But let's go back and just make them very quickly redistribute surplus across LOBs. So now we only have one portfolio. Let's do that. Let's fix the seed. Let's call it 1, 2, 3, 4, 5. Okay, and I think you might remember we're doing about 492 million simulations, 100,000 simulations for the conditional distribution, 100,000 for the, unconditional distribution, 100,000 for conditional given the first year's in distress, so we can get the distributions for subsequent years, the first year in distress. Every triangle's got 410 cells, so we're simulating from all these correlated log normals, and we're going to do that 200,000 times, so we're doing about 492 million simulations from correlated log normals. Now for the other scenario, same model, same forecast. Instead, we're going to calculate the Solvency II 1-year risk horizon metrics without any distribution, which means that every LOB is ring-fenced. So there are 6, if you like, portfolios now. Let's do that now. Again, 492 million simulations. Actually, each one of those 492 million simulations for each of the fungibility scenarios, full fungibility, no fungibility, took exactly 5 minutes, and that's why I sort of paused the video. Well, let's look at the two situations. Let's look at the settings for number 2. Number 2, we've got no fungibility. So surplus redistribution methodologies are switched off. The portfolios, well, there are 6 of them. So there's no fungibility there. Let's look at the summary there. This one must be, yeah, there's only one portfolio. So fungibility is turned on. Let's look at the summary there. So now, okay, let's look at those in terms of SCR, 68 versus 63. Well, it's not that much more. Why is that? Why is it that we're finding that not allowing for fungibility across LOBs doesn't increase the SCR really by all that much? I think there are kind of two reasons for that. The first year in distress at 99.5%, I think that's in the setting. Must have meant that in aggregate, the losses were very high. And the main driver of the losses, which we'll see in a subsequent video, video 5.6, when we discuss distress samples, the big losses are coming from LOB3. That's really the largest loss. And then we've got LOB1 that, you know, in terms of the losses, the value of the losses is 20%, whereas LOB3, in terms of the value of the losses, is over 75%. So it's really, you know, when the aggregate is in distress, it's mainly coming from LOB3 in terms of the value of the losses, and LOB1. And, you know, any surpluses in LOB4, LOB5, LOB6 are going to be minuscule. And also, when you're looking at the 99.5 percentile, a lot of the losses will exceed the mean, which means you won't have a surplus. And as a result of those two phenomena or conditions, then you can see the risk cap was 68.68 million versus 63.75 million. That's in aggregate, not really much more. The total capital as a percentage of the mean undiscounted BEL is 99% versus 98%. What about the actual MVM? The market value margin is 12,624 versus 12,133. So, you know, whether you make, when you make the LOBs non-fungible, we're not talking here about a hell of a lot of money as a percentage of the total capital at inception. You've got your metrics, you've got your summary, you've got your charts, which you've seen all these before. Okay, all right, so that sort of almost concludes that. I mean, one thing that you can also do, I mean, by default, when we did our simulations, we also assumed that we have forward fungibility in terms of calendar years. In other words, well, in the first calendar year, you don't have any surplus because, you know, if in aggregate you are in distress, which means you reach the 99.5 percentile, there's no surplus from any LOB. In the second year and so on, the losses, the losses. Remember, Solvency 1 is always analyzed under the condition that the first year is in distress. Okay, when you look at the second year and so on, you can start accumulating surpluses by calendar year. Okay, what does that mean? That if in the second calendar year some of your losses, the aggregate loss is less than the mean, or for some, the aggregate loss that we're looking at, the aggregate loss is less than the mean, well, that surplus can be used to pay for losses in the next year. Or you can actually turn it off and say, no, I don't want to redistribute surplus by calendar year going forward. So you've got those two options. And I think if you switch on none, again here there won't be, because you're looking at the 99.5 percentile, there won't be really a major shift. Okay, so spend a bit more time on our website, and don't hesitate and come back to us with questions. Thank you for that. Bye.